Welcome to the IPX True North podcast, where we connect people, processes, and tools.
All right, well, welcome back, everyone. My name is Brandy Taylor, and today we're diving into something that has the power to transform not just organizations, but the next generation of humans entering the workforce. So, Purdue University has taken a really bold and what I like to say forward-thinking step by integrating CM2 and PLM directly into its engineering technology curriculum. And this gives students real-world tactical skills long before they ever step into their first job. So this isn't theory, this is the language of modern product development, change control, and digital transformation. So joining me today is one of the professors at Purdue University who's leading this effort. He is capable, very capable, and is very excited about helping students graduate with the systems thinking, problem solving capability, and cross-functional awareness that the industry really needs. So Professor Travis Fuerst, thank you so much for joining me today.
Hello. Thank you, Brandy. Thanks for having me.
Yeah, this is super fun. So we've had an opportunity to come and speak to some of the kids in your classes this semester, which has been really fun. So I appreciate that invitation. But I think in general, I think our industry in our network here probably doesn't know a lot about you or what's going on at Purdue. Do you just go ahead and just start us out with a little bit of an introduction of yourself for our listeners?
All right. Well, I'm a graduate at Purdue from circa 20 or 2000 and then 2002 with a master's in product lifecycle management. And from there I the went into industry in the PLM world, working for Dassault, for Novia specifically, so PDM. From there I went on to work at Boeing on the 787 program, cut my teeth there, did a little work on the 747-8 and then the KC-46 tanker programs as a SME in product data management, specifically in Novia at that time. I transitioned to IT, got into a lot of continuous improvement, supply chain systems, and then had the opportunity to return to Purdue as a professor of practice in this space. So I've been back at Purdue since 2017, teaching in what was computer graphics technology, and then we transferred over to School of Engineering Technology, where we really belong. Now I get the opportunity to teach most all future Aero, ME, MET, IE, IET students coming out of Purdue, introducing them to design for change, product lifecycle management, PDM, and all of that I explain to them is bound up under you know, under the process of CM2. They don't grasp that at that level, but understanding that the tools are not the solution. It's your processes. But that's kind of where we've been working with this for about CM2 has been part of our program since I believe about 2015 or 2014 when we reworked a PLM certificate program that had been produced for Boeing back in 2007 when I was there as part of that. And it was reworked to incorporate CM2 into the PLM certificate program, which is now being relaunched as part of a PLM MBD TDP digital enterprise certificate to teach industry folks about that. But bringing all that back into the college curriculum has been very important.
Very neat. So I love this for one. I think that,
Mhm.
often at IPX, we find a lot of individuals that come to us for training and for services because they didn't learn this in college or in university. So this is not common that this is the case. So to me, that makes me super excited just because I think understanding some of this before we go into our first jobs and learn whatever is happening there, right, wrong, or indifferent, often typically by how it doesn't go well.
Yes.
Which is the best way we learn, unfortunately, but that's the case. So I think having some knowledge and some, starting out in your career on day one with some understanding of how this is supposed to go, I think really sets these individuals, aside and apart from some of the other degrees and other curriculum that they could be taking leaving the university. So thank you for doing that.
Yes.
Um, And I think, so your background, all of that, it just makes a ton of sense that this was something that you were passionate about. You saw it, and now you're bringing it into the university. Is there anything
Yes.
specific that sparked your interest in pulling this into the engineering technology curriculum?
Well, for me, at Boeing when I started out, when I cut my teeth, I was in learning, training, and development. So in some way, shape, or form, my entire career has been centered around training and education. I will also add the fact that I retired from the Army Reserve, and much of that time was spent as a drill sergeant or, running basic training, you know, teaching and training, what I want to say, kids of the same age, in that environment, and or as a company commander leading the battalion, or sorry, leading the company of drill sergeants doing the same thing. So my goal has been to be as effective as I possibly can with as many folks as I possibly can with the least amount of effort. Um, and being at Boeing, teaching engineers a new way of doing design, because the last major airplane program before the 787 was the 777, and things weren't as collaborative as they are. It was a digital aircraft, but it wasn't as collaborative as it is today. The interface with, at the time, CATIA was a total transformation, going from Unix-based V4 to Windows-based V5, uh, in teaching them how to design in the context of a PDM system. Yes, they had a PDM system, but again, it wasn't as collaborative. Every night you're checking your stuff in, and running clash detection and doing these things. So bringing that forward and seeing the problems we had in transitioning engineers from the old way of doing business, if you will, to this new, more collaborative way. I now get the opportunity to teach engineers, future engineers coming out of college, to model in the context of a PDM system. Many of these kids come out of high school. They already know CAD. They believe they're experts in the tool. You know, through a lot of kicking and screaming and gnashing of teeth, I transform them into relying on a PDM system instead of a file folder with crazy naming conventions. Some get it right away, some don't. But my goal is not necessarily that the, the students I'm talking about are talking about freshmen and sophomore. Uh, the class where we teach straight up CM2 is a 300 level class for juniors and seniors, but they're first introduced to it as a freshman or sophomore in the context of doing the work. So by the time they get to that junior or senior level course, they have some context to work with. So going back to that, it takes some students get it right away, some students don't, and they apply it to their clubs and their team builds, and some take a little longer. They think it's better to do it the hard way until they realize this is much bigger than my, 5 component model that I can print on my 3D printer with my buddy. And then they start to realize the power. Actually, right now we're going into week 8 of the semester, and they're starting to do assemblies. So right now they've only been creating parts. Now they're going to be assembling parts, and they will start. The light bulb comes on for many of them when we get to assemblies and how they're managed inside of a PDM system versus a file folder where links break and things don't connect. And so, yeah.
I like where this is going. So it's some of that, engineering so many times thinks that, they should be designing and testing, and all that's really important. Certainly can't say that, right? Like I'm an engineering, I have an engineering degree. All that is very important. But if you can't finish and you can't release it and you can't spread and utilize that data across the organization, that's a big miss. So I love where this conversation is going, and it sounds like you guys have infused some CM2 as early as 2015. I think
Mhm.
it is what you said, but I know you have now two standalone courses. One is an undergrad course that you're teaching, and also one that's a graduate level course for credit. So tell me, the need for, the decision to go ahead and make this a standalone course.
Yeah, so essentially, we have an online master's program for School of Engineering Technology, and we added the CM2 course as one of the offerings for that. It's an 8-week course because everything's all about the engineering. Like I say, we I just want to design, I want to release, I want to get, build cool things. But nobody really instructs within the engineering curriculum how to manage the data, how to manage change. So we saw a gap there. And that's been a very successful course at the graduate level, and it's not difficult to teach. Just like if they were to attend corporate training, they're coming in with experience. These are folks that are seasoned engineers. They've been out there, and then they have the aha moment, like, oh wow, this is the answer. So it's not too difficult to make the leap to a graduate course. Now, we had a course that was 313 in our it's manufacturing engineering technology 313, which is the business of managing product data. Traditionally, that course had been how to configure, install, or let's say how to install, configure, and use Team Center. Okay, that's great. But so what? There was little theory or background to that. So we took the opportunity to say, okay, this is less important because now those skills have been pushed down in terms of the usage of it to the lower level courses, like the course I was telling you about and some of the other undergrad courses. So they learn how to use it. They learn how to um, create an ECO, work through a workflow. Let's focus this course more on why. Why are you doing this? Because there's a little bit of why in each one of those, but it's only enough so that the students begin to accept it and realize that this is important. Now we're going to get into the nitty gritty. And so we've infused the CM2 curriculum. We actually use the CM2 textbook to take them through the first, I believe, 6 courses in the CM2 library. Each week we cover half of one of those courses. So over 16 weeks, we cover them all. And we work through several assignments. The aha moments start to click. Students that have had internships realize where the gaps were, where this could have been implemented, or where it was implemented or it wasn't implemented properly. So even though they don't have the context that a graduate student or somebody coming out of industry would have, we can still marry it back to things they've done, even within their school experience. Many of the students are in clubs, engineering clubs, SAE Baja, Formula, EV, they've got propulsion, Purdue space programs, hybrids, and they see that, oh wow, we're really doing a lot of extra work and burning time and burning resources and wasting things. And so we've even now partnered with those clubs to help implement CM2 and these types of strategies on those clubs at a student level. Now, it's not because they have to do it, it's because they see the value and the light bulbs really start to go off. And we see, in they're incorporating PDM, Team Center, Eris, design principles throughout, um, outside the classroom.
So those teams that they're in that are outside of class are, bringing them those real world applications. And now with the skills they're learning, like you said, it's about the why, right? Is what's the importance of managing our product data accurately and efficiently, and there's best practices around these things, and so let's figure out how to do this the right way, instead of just whatever ways that we tend to navigate to. So to me, I think the why is really important. And um to me, I think what we see out in industry as well that aligns really well with what you're talking about is how product data can be one of the most expensive risks a business can have. So bad product data is a huge problem, and this is what costs so much overhead, so much money. And people think that change management, configuration management is just the cost of doing business.
Mhm.
And that's a very huge miss. So, there's so many ways that we can be better at this, and being good at product data and having data we can trust
Yep.
is truly what drives predictable revenue and margin protection. So for me, this is so fantastic because this is not something that we find many people really realize in the engineering realm until many years later. They just think that they should continually evolve. They should
Yep.
change data all the time, right? My job is quality improvement, fix problems, and all of that. But they don't think about that larger picture of what that means. So yes, I'm a big fan of this.
And I have it prompted a story. So one of my students that didn't go through the CM2 course, just went through the design course. And we were using a PDM system. And he was the lead on the Purdue ROV, it's an underwater rover program. Uh, and so he was the design lead, or I can't remember, leadership position. And he came in to me really frustrated one day, and he said, Professor First, we just we just wasted, I think he said, 15 hours of machine time, the design or the machinist and a titanium plate, and we cut the wrong part. Or it was the wrong one. I said, so what happened? Well, we needed to cut the part. So I asked the individual, or the individual who's doing the part said, can you send me the part? He's like, well, it's in Eris. It's in the PDM system. Send it. Well, I don't want it in there. Just send me a part. Send me the part. So they sent it outside of the PDM system to him. Nobody reviewed it. They put it on the machine. They did all, well, they did all the cam work, put it on the machine and cut the part. And then they found out it doesn't fit um, the, it doesn't fit the rest of the build. So what's your change process? Oh, well, we just go tap each other on the shoulder and say, does this look good? Does this look good? So it provided the opportunity to enlighten him about formal change and explaining to him it doesn't even have to be automated or through a workflow. Did somebody sign off on it? Do you have a record of who said this was okay? Do you have a record of, when what changes were made? Do you even know it was the right part? But those are the kinds of aha moments that students are starting to get. And because they're having, as I explained to them, this is no different than industry. It's like what you just experienced happens every day in any company. So they think that it's unique to them, and they don't realize these are the actual problems that they're going to face. And then he actually presented on that at a conference explaining, and everybody's, all the industry folks, the eyes lit up like he just had the same problem we have. He's learned before he gets here.
Yes,
He's getting the experience before he actually walks in the door to know
I
not to do
love that. I love the real world challenge that students are learning, right? I think that that's it. Those are exactly the things that happen in industry. We hear it all the time, and
that.
that's the intervention, the rework that we hear, and it is common for us to find in our intervention workshops that it is common, a minimum of people's time, 40% of people's time is spent doing things like that, the rework, the intervention, and all of that. So, yeah, and it's all based on, maybe not great processes and not great data. So, how do we make sure that we have data we can trust, that we're spreading goodness? So, I love that. So, the realization that engineering is not just about design, but it's about the flow of requirements, right? I
Exactly.
love that. Any other thoughts from your perspective of what students walk away with that kind of give them that competitive edge?
At, those that don't go on past the entry level course, they at least come out with the knowledge that what I create is not one and done. I really try to instill in those courses that we have design intent. What is this part supposed to do? Not what does it need to look like, but how is it supposed to function? Because, I've had students early on when I started teaching back here at the university, I would have students, I would show them how to create the model, very succinctly. It must perform a certain way. This is how you model it. This is how you infuse design intent, using constraints, using dimensions. But I would have some students that inevitably say, this is what the part looks like. They wouldn't watch any content that I created. They would create the part, it would look wonderful, and then it would get a grade and it would be like a D, or a very low score. Well, it looks like your part, well, it doesn't work like my part. They don't understand that modeling isn't about just what the part looks like. It's about how the part functions. I essentially equate it to programming the model. You need to program the model so that somebody can come behind you and make modifications to that model without blowing it up. Just like you would code and you would put notes in your code and create clean code, you need to do the same thing with your model. So from that perspective or that level, of course, they're getting that out of it, and that you must have some form of data management and process to control change because things change over time. Things are going to change. Your first iteration is not going to be your last. And I think having that epiphany in these courses is a big win, um, because they realize it's not just me. This isn't my thing because they're so used to like building something and printing it off the 3D printer and forgetting about it today. For the CM2 courses, the undergraduate CM2 course, just the realization that this is much bigger than the part they're building, getting into the requirements, the design baseline, all of that is like, wow, this is much bigger than I thought it was. And realizing there's so much more opportunity for error, but there's so much more opportunity to fix things before you get to a point where there is error and realizing the impact of the error as it goes, down and up the V model, and seeing that there's a process to capture all this. I think having that knowledge going out into the workforce really gives them a leg up on the competition in terms of their peers around the country because most universities aren't even touching this. It's all engineering theory, computational fluid dynamics, you know, FEA, but they don't really talk about how you manage that data and how you can use that data to facilitate change, nonetheless, managing the change itself, the ramifications of making this change, all of how the ripple effect of how it affects so many different things. Most students don't have that concept until they get out into the workforce. And even then, are they exposed to it in that first job? Because somebody else may be just giving them a task to do, and they don't even realize the impact of the thing they're doing if somebody else is managing the larger, scope of the change. So I think that perspective helps them.
I couldn't agree more. And, speaking to the students when we were in last time, I loved how, some of them are going into aerospace,
Mhm.
but you ask of them all about what they want to do. And some are saying they want to improve processes. Some want to, manage manufacturing processes. Some are want to talk about supply chain, so it was a really interesting mix of the different things that the students want to go into and how this to me uh, is a value to that because it's really truly the integration, right, of the organization. So they're opening their eyes that it's not just I'm going to design and test and I know this is good, then I'm going to, throw it over the wall and everybody else can do their thing. It's the bigger picture impact there. So I think about, from your perspective, how does teaching CM2 in the university help students shift from a task level thinking to systems level thinking? Tell me a little more about that.
Yeah, yeah, systems level or strategic, they think bigger than themselves. And that is really the hard part about student, especially when you get to the freshman, sophomore, junior, senior, maybe they've been to an internship and then it clicks a little more, especially usually by the time they take the CM2 course, the 313, they've at least had one or maybe two internships, and they can directly correlate what we're talking about and realize there may have been more to the task they were given. They were just given a task, to perform and not realizing that there were certain requirements behind that. And understanding how, in terms of the systems aspect of it, how they fit into the larger system, because I don't think they get a lot of that knowledge, especially in the courses they take. Because it's all the classes in college typically are one and done. I'm taking thermal, now I'm taking Calc 3, and there's really nothing to tie it all together. Unless you have a really good advisor or a professor that kind of walks you through why you need this, so you can go do this course, so this how these courses relate. They are all interpreted as individual modules that I have to complete to get my degree. Very few students, I think, see the curriculum path that is developed by the faculty, which I think is something that needs to be worked on, right? There's very few things that tie these courses together. One of the things we're trying to do to fix that within SOET is we're trying to have the same assembly that they'll create in my course, which is the design course, Design for Change, take that into the documentation course where we do GD&T. Now you're going to put GD&T on this, and then they take it into the machining course, and then you now machine it. And now you can see that we're not throwing this thing away and never touching it again. No, you're going to walk this through the entire process and see, at least from the design to manufacture, the system that's required to get this from point A to point B and to get it there accurately, right? And if you need to make a change, how does that change occur? In a PDM system, I hope, and documented. You're just not like updating a drawing, and getting them away from uh, thinking only in 2D with drawings, thinking model-based definition, PMI. The model is the authority because we're still hung up in many ways on drawings, 2D entities. And that's one thing I try to instill is that, hey, the model is the authority, the drawing is a derivative. That's the way things are, should be now. Now, in some places, that's not the case. Drawings are still the authority, but we should be moving away from that. So but from the systems aspect, moving from that individual contributor to thinking from a systems, I think another advantage of this is the students that are coming out with this knowledge are going to hopefully find themselves in more strategic, or I want to say leadership positions, not necessarily management. I hate to push any college student into management too early, and I tell them that. But at least in that advisory role, hey, I learned this new thing in college. Why aren't we doing this? And at least sparking the discussion with their lead engineer or somebody that may not be aware of it. Maybe just be doing it the old way. So helping them get that leg up and infuse these new, or they're not even new, these concepts into the workforce.
Yeah, I really like how, what I hear you saying is you're teaching these students the business of running a business.
Mhm.
And what does that mean, right? Is giving them that broader purview of how an organization should work and can work and needs to work. So almost giving them that interest to not just focus in their silo, that they have to reach out more and make sure they understand, the handoffs and what's happening next and what good or bad data does to the next person, right? Because in the end, we all need to rally around a profitable business. So if we all can open our minds better about the bottom line and waste all that and just everything of what your data does, and if you can have data you can trust, it certainly sets up everybody for a much better position to be in, more efficient, effective way of working.
Absolutely. And I think that's another thing, waste. Students don't understand what waste is. They're just okay with that. I'll just redo it. Redo it. It's like, you don't understand. You're not paying for, or
Yeah.
the customer is not paying for you to redo it. You have to do it. It has to be value added, done right
Mhm.
the first time. The customer has to care. And, if you're not doing that, you're paying for it. It's coming out of your bottom line. And I don't, that's another aspect that the students come away with, that intervention resources, these things, they're not providing income for you. This is money you're just kind of throwing away. And there's
Yeah.
and it doesn't have to be that way.
Yeah, yeah, completely agree. Thinking about, the exposure to digital tools, I really love that they're getting hands-on PLM exposure in your course, so they get that real-world application of what we're
Mhm.
talking about. Again, it's not just the theory of how we should
Yeah.
be managing change, making good decisions. Tell me more about, some of that digital exposure, because I know digital transformation's big.
Mhm.
Single sources of truth are really important, automation and all that moving forward into the future with AI enabled engineering. I think that there's just so much here. So tell me more about the importance of exposure to these digital tools.
This goes back for me. It goes back to when I was, first of all, my master's was in product lifecycle management. So I picked up on the database stuff, the PDM in my graduate program. I think actually in my undergraduate, I took a database class. I'm like, this is what I like. Yeah, I can model. Okay, this is fun. But I like the data management. And then I parlayed that into, you know, 2000, early 2000s was the PLM boom, right? The new buzzword coming on and everything. So, hey, I cobbled together a degree in product lifecycle management and then got to go and work for, a PLM, if they, as they would call themselves, a PLM provider, in terms of Dassault. And I got to, really understand the tool. I didn't know what the tool really did. I mean, coming out of my undergrad and my master's, I was like, I understood the concept, but I really didn't understand the basic stuff like effectivity. I could teach it in a class, but I didn't understand it. So until I went to work for one of our customers as one of them, then the light bulb went off, right? And I'm like, oh, that's what effectivity is. I get it now. That's what a change order is. This is how, I've been working with the objects for years. I'd be teaching it in a class, you know, just going by the book and teaching this stuff, but I really didn't understand it. And so for me, being able to come back to the university and provide, and then I go become an educator, a workplace coach is what I was within Boeing, teaching engineers how to use these tools and provide the context of what they're doing in terms of in their processes in the context of the tool, and seeing that really had to give them the why you need to do this, because nobody wants to, they feel control, they're losing control because they have to do it in a PDM system, so therefore I'm losing and have to win them over. What's in it for me? Why should I be doing this? Because everything we taught was in the context of the process within the engineering process inside the tool. It wasn't go take tool training and then figure out how to meld this into the process. The tool training was the process. Coming back to the university, now I have the opportunity to prevent students from having the aha moment so late, because they get, I tell them what I'm teaching you may not come across as valuable, or you may not get it. It may be your first internship, it may be your second internship, it may be 3 years into your first job before the light bulb clicks. But I don't want the first time you see this to be at your internship. I don't want it to be at your first job. I want it to be the third or the fourth time that you've seen this stuff and the light bulb comes on faster. Because for me, going back that far and not, I was literally teaching industry professionals how to use the PDM system and explaining concepts that I didn't even understand until I became the user. So if I can at least front load that initial experience and the light bulb comes on faster, and I tell the students they cuss me, they they hate it, and it's like that's no different than an engineer. You're no different than anybody in industry. Nobody wants to do this until you see the value and embrace it. So that's kind of where I see the value of putting this stuff in the classroom, even though it's a very intensive, technology wise and infrastructure wise to do it. It requires a good IT team. It requires knowledge and understanding these tools and systems and keeping them up. Because I tell students, if the system goes down, this is an enterprise system. This isn't Microsoft Word. It has problems. There are multiple servers. I show them the architecture and, understanding the complexity of this thing. This isn't just, it just doesn't happen because I said so. And so having that understanding too, that, if things break, if processes change, it's not the end of the world. And guess what? This is your life going forward, because they're so used to uploading a file to a website, an LMS, and saying submit and I'm done and I walk away and that's it. Having them go through a workflow, now they get all worked up because why is this so hard? It's like, well, this is what real life looks like. It's not just upload file and say done. So giving that exposure too.
Yeah. Yeah, I like it because I think it helps people understand that, first time yield and process variability is not just something for the manufacturing floor, right? So, these things affect us upstairs as well, and making sure that we have that consistency across, and so that way we have, we make sure that we're like you said, given the right data, they got the right information, they're building the right part. All of that is extremely important from a quality perspective as well as reputation and all sorts of things. So there's so much power inside these individuals' hands when they go into industry. So helping them be career ready on day one is a really cool opportunity I think you're bringing to the courses. So very fun.
And I'll add, it also makes them double check their work because so many they hit submit and they walk away.
Yeah.
But many have been caught. They submit and it wasn't checked in. They walk away. They didn't check the workflow. I turned it in. No, you didn't. You missed the deadline. Because you have to check you have to check and double check your work. And you're an engineer. The things you want to be an engineer. The things you are creating affect people's lives, and having that realization too. It's like you're not just walking into something that it's good enough. It's like you have to make sure that it's good enough so we don't have corrective action, so we don't have accidents, so we don't have these things happen. So every piece of the implementation of these systems, it goes to the core of what they want to be, and the importance of making sure that it's right the first time.
Very good. So I guess, thinking about, your experience so far with the students, if there's anything, that you would share to any students about, being interested in configuration management or product data or anything here, is it any words of wisdom for other students out there to be searching out this kind of information?
Mhm. Yeah, I would say just, just like back when I was working with industry professionals, in the mid 2000s, be open to change. Things are changing a lot faster than they used to. Um, don't fall on don't fall on the system, or excuse me, don't fall on the tool is going to fix your problem. You really have to focus on your process and your people, and the tool, find the tool that will facilitate a good process. Also, it's a common thing we do when you implement, when you have a process and you then the process is solid, you've gone through it, and then you implement the tool, you have to start thinking about what you're doing. Are some of the steps necessary because now you're using the tool? Don't, you really evaluate the things that you used to do and say, is this even necessary? Are we just doing it because we used to do it that way? We're not thinking in a new way. So you really have to reevaluate each of the steps in your process once you implement the tool. But the tool is not the solution, which most folks, especially students, because students will come to me and say, "Hey, we want to do this with the club specifically. We need this tool." It's like, okay, stop, back up. What are you trying to do? What's the end result? And actually, that's not the tool you need. You have the tools necessary. You just need to fix your process. And that's not just a student problem. That is a industry professional problem too. We always think the next shiny tool is going to fix our problem, and it really is the process. And that's getting out of the technology piece. We got to get back to tools and people, because the people too, as we know, what is it? Culture will eat strategy for breakfast, innovation for lunch and dinner. Well, yeah, no matter how good your process is or how good your tool is, if the people aren't on board with it and you don't give them the whiff them or the what's in it for me, that you're probably not going to get very far with that. So focus on the processes and the people, and then the tools. I would
Yeah.
say.
Oh, yeah. So, and tools, they'll sell themselves as solutions. Everyone wants to see that, and we see that in industry as well as
Hmm.
my current tool, and so I need another tool to do what I think my current tool is not doing.
Yeah.
And I think it's again, it kind of all goes back to requirements, right? It's the same thing, and when you're designing product, is how do we have clear requirements so we can make sure that the tool's doing what it needs to do? Because these tools will automate anything. We said that the other day. They'll automate your credit process as well as a good process. So, we want to make sure that we got good goods going in. And it's not just a very expensive repository, right? Like if you're just using it for your repository for your data, that's, pretty expensive solution for that. So how do we make sure, like you're saying, is challenging that process, making sure the process is working for you, and don't just like, accept the status quo because this is how we've always done it. Because what
Mm,
worked for us in the past doesn't always necessarily work for us today or help us move forward in the future. So
exactly.
that continual improvement mindset is important. So very cool.
Absolutely.
Well, Travis, I think many of our contacts within industry reach out to us at IPX for CM2 candidates. So, I would love to be able to help connect some of these great students, with our network as well. So as they, I'd love to stay in contact with you. And if there's anyone that out there listening that would like to connect, they can either reach out to me, but is there any way they could reach out to you directly as well to learn more about maybe some of these great students or anything more about what you're doing?
Absolutely. Feel free to tag me on LinkedIn, Travis Fuerst, and then email. It's my last name, FUERSTT at purdue.edu. Yeah, absolutely. Would love to connect.
Right. Excellent. Thank you so much, Travis. I really appreciate your
Randy.
time and all of the awesome work you're doing. And it's been really fun getting to know the students and seeing what they're up to. So appreciate that.
Awesome. Yep. And I thank you guys for supporting and being there, and Randy for your dedication to it. Because, coming up and having people come in like yourself and talk, they realize that I'm just not, I'm not lying to them. Because a
Yeah.
lot of times with professors, it's like at some point, it's like I keep talking, I'm telling you the truth. But having you guys come in and reinforce the concepts and them seeing it, listening to your experience on top of ours. So anybody that's out there that would love to, I would love you to come in and be a guest speaker. I have opportunities for that throughout the semester, especially in this class. Engage with the students, do it virtually, do it in person. We can make it happen. They really like, the industry guest lectures that I have towards the end. After I've given them all of the, background, they muddle through that, and it's like now they know at least what to listen for. They understand the vernacular, the acronyms, so it's like they can actually consume and then ask questions. So this is good.
I love it. Excellent. And we have a job board, I know, on our website too, if anyone's not aware that we are constantly searching in industry for jobs that are requiring CM certifications and expertise. So happy to try to, that's one of our core virtues is trying to connect people with great careers and jobs and things as well with this great knowledge. So thanks so much, Travis. And
Thank you,
well, yeah,
Brandy.
we'll talk again at some point. Thanks.
All right, take care.
Thank you for tuning in today. Don't forget to subscribe and review the show. And for more information on IPX, visit ipxhq.com.